So very good afternoon all the students. Today we will see the next part of the ductile detailing of IS 13920 1993, that is the wave reinforcement. Okay, so what are the basic criteria, what are the basic provision for the wave reinforcements are given as per the codal provision we will discuss in this lecture. Okay, so first of all what are the basic requirement of wave reinforcement to ensure that the beam capacity will govern by the flexure and not by shear reinforcement, wave reinforcement. So for that, carry the vertical shear force and prevent the diagonal shear cracks. Protect the concrete from the bulging outwards due to the flexure and prevent the bulging of the compression bars. So these are the main factors which governs by the flexure. Okay, next is web reinforcement shall consist of vertical hoops, and the details requirement are shown in figure number 6, 7 and 8. Okay, this is the figure number 6. So this is the wave of the beam. Okay, so the hooks are provided like this. Okay, 4 bars are extended, 2 in compression, 2 in tension side. Okay, and the as per the ductile detailing, the stirrups at the end should be inclined to be an angle of 135 degree in a proper way. Okay, the end of the stirrup are bent up at 135 degree. Such a stirrup do not open during the strong earthquake shake. Okay, so during the construction itself, many times the workers are not able to bend these stirrups. Okay, they just do their usual work and bend the stirrups like in 90 degree or 60 degree. Okay, so the anchorage of these stirrups is very important as far as the earthquake force is concerned, because during an earthquake the shaking will take place, which will directly transfer the earthquake force to the structural member like beams and columns. Okay, so because of that the stirrups may get break and toppled out. Okay, so in order to avoid this, the stirrup should be bent at 135 degree. Okay, so this is the preferred diagram. Okay, preferably 135 hooks in the adjacent of the stirrups of the alternate side. Okay, so this is a typical pattern given. Okay, then in compelling the circumstances, the wave reinforcement may also be made up of 2 pieces of the reinforcement. Okay, so this is a 2 beam reinforcements are provided. We can also provide either we have to bind the stirrups like this way, and then additional stirrups of this crosset in the form of crosset can be provided like this. A U stirrups with 135 degree hooks can be provided, and along with that 10 diameter extension minimum 75 mm and a crosset with a hook at the end of similar to U strips can be adjusted to this one. Okay, then the next is the minimum bar of 6 mm. Okay, now 6 mm is outdated, so we will use 8 mm instead of 6 mm. Okay, so minimum bar of 8 mm for the span less than 5 meter and 8 mm for span greater than 5 meter can be used. So instead of here 6 mm we can use as 8 mm, or instead of 8 mm we can use as 10 mm. Next is for the stirrups not less than 50 mm for the column face, the minimum spacing is 100 mm. So this is the typical arrangement. Okay, so location of the amount of the vertical stirrups in the beam, here we can provide the spacing at the rate of 2D, and here we can use as a D/2, as we know that the critical shear will occur at the support only. Okay, and as this is a joint, the earthquake force is also very predominant at the support, so therefore the stirrups can be closely spaced, okay, near the support, whereas at the center the bending moment will be maximum. Therefore in this case the shear the stirrups can be provided at the distance of D/2. Okay, then the shear force to be resisted by the vertical hoops. maximum of the calculated factored force as per the analysis, then the shear force due to the formation of the plastic hinge at both the end of the beam plus the factor gravity load on the span. So this point can be considered. Next, column and frame members subjected to bending and axial load generals. Okay, so it is all about the column frame. So these requirement can be applied to the frame member which have the axial stress in excess of 0.1 FCK. Okay, under the effect of earthquake force. So the minimum dimension suggested by the code is, in general, it should be should not be less than 200 mm in frame which is having a beam of a span greater than 5 meter. Okay, it should not be greater than 300 mm. Then the column having unsupported length of greater than 4 meter, then it is 300 mm. To avoid the very slender columns, okay, a column failure before the beams, the dimension should be B by D ratio should be greater than equal to 0.4. So since the confinement of the concrete is better in the relatively square column than in column with a large width to depth ratio, okay, then the provision of the longitudinal response. So under this lap splicing is there, it should be provided only in the center half of the member of the length. The length should be equal to the tension splice and the hoop to be provided over the entire span of the splice length. Then the spacing should not be greater than equal to 150. Not more than 50% of the bar can be spliced at one section. Okay, more than 50% of the bar is there, then the lap length of 1.3 LD should be provided. Then the transfer reinforcement, figure number 9. Let us see figure number 9. This is the figure number 9, transfer reinforcement. This is the vertical bar is there, this is a closely tie is there, this is the extra link is provided. Okay, this is a steel reinforcement provided in column. This is a 4 bar column, this is a 8 bar column. Okay, so this is a typical arrangement of a link is provided, how the link can be arranged as per the number of bars provided in the column. So let us see what are the provisions. So provide the shear resistance of the member. Okay, then confine the concrete core, thereby increase the ductility. Then provide the lateral resistance against the buckling to the compression reinforcement. Then prevent the loss of the bond strength within the column of the vertical bar splice. Then closely tie of 135 hooks can also be provided with the diameter of 10 mm extension. Okay, so as similar to the beam case, here also the links can be properly encouraged by using 135 degree band. Okay, then spacing of the hoop shall not be exceed B by 2. Okay, where B is the least lateral dimension. Then spacing of the parallel legs of the rectangular hoop shall be less than 300 mm. Then provide the cross tie if possible if the length of any side of the hoop is greater than 300 mm. So these are the typical provisions which can be provided in the columns. Then the special confining reinforcement provision. Okay, provide the over length if L0 from each joint face toward the mid span, L0 on either side of any section where the flexural yielding may occur under the effect of earthquake force. Then the length of L0 shall not be less than the larger of the least lateral dimension of the member, 1/6 of the clear span and 450 mm. Okay, this should be whatever the minimum value is there which can be provided. So these all are the provisions of the design of the compression member that we have already seen, that you have already seen in your RCC, I think. Okay, as per IS 456 these clauses are same. Okay, then the area of cross section AS can also be used. Okay, so this formula is also circular hoop. Okay, circular tie spirals formula is available in IS 456 also. Okay, so this formula is taken from the same code, ASH equal to 0.09 SDK, FCK by FY, AG by AK minus 1. Okay, and the cross section can be calculated for the rectangular section as 0.18 SH, FCK by FY, AG by AK minus 0.1. So this is the formula which can be applicable for circular as well as for the rectangular hoop. Okay, so these are the some nomenclature of the formulas are there. Okay, notations are there. Then this is a typical arrangement. Okay, you can see that. So at the bottom, so at least D should be HC by 6 or 450 mm. Okay, this is the height criteria. This is the beam. So we can see that after the foundation, okay, where the tie beam or the are provided, so the minimum height should be provided as HC by 6 or 450 mm. Then at the upper of the beam, the spacing of the tie should not be more than D4, but not less than 75 mm, or nor more than 100 mm. Okay, so HC by C formula is there. HC is the center to center distance between the two beams. Okay, we can see that center to center, or you can say that outer to inner distance between the two beams. Okay, and then lateral spacing, lateral vertical bars is provided in the middle half of the column. Okay, then the spacing of the tie in lapping length should not be more than the smaller of the D by 2. Okay, and one thing you also notice that at the junction of the support, okay, at the junction of the support, the lateral ties are very closely spaced, and whereas at the center also it is also closely spaced. Okay, so it means that the earthquake forces are very predominant in the zone of the joint and at the center also. So therefore, in order to avoid this confining reinforcement is provided at the joint as well at the center. Okay, so this point should be considered while providing the detailings in the reinforcement. Okay, as per the codal provision of IS 13920/1993. Okay, so these are the some of the basic of structural detailing parts that are comes under the codal provision of IS 13920/1993. So it define how to properly place your reinforcement as per the ductile provisions. Okay, and this detailing can also be done, okay, by using IS 456, but the IS 456 provide the provision of the normal detailings, whereas IS 13920 provide the provision of the ductile detailing. Okay, so for the earthquake engineering, 13920 is recommended. Okay, so we will start with the next topic, that is the next chapter in our next class. Okay, thank you for your kind attention.